In this video, we'll learn how to add and subtract rational expressions, and this is one of the harder topics in the chapter on rational expressions. So to begin, let's kind of review how we add and subtract rational numbers, or just fractions. So at the top it says, recall, to add fractions with like denominators, all we do is add their numerators and keep the denominator that they have alike. The same is true with rational expressions. If the denominators are already alike, you just combine the numerators when you add or subtract. So 7 minus 11 is negative 4 over 2r squared, which is the common denominator. Now I can simplify because 2 goes into 2 once, it goes into 4 twice, and I end up with negative 2 over r squared. Let's look at this second one. Again, this one already has a common denominator. Both fractions have a common denominator. So I'm just going to add the numerators, m plus p over m squared minus p squared. Now, here is where rational expressions are more difficult than fractions. I don't know if I'm finished yet or not. I know that I can't cross-cancel parts. We learned that in other videos, in other sections. But I can look at my denominator and I see that it's factorable. So leaving my numerator as m plus p, I'm going to factor this denominator, which is the difference of two squares, so into m plus p, m minus p, and now it's obvious that the m plus p's will cross cancel, and what I'm left with is just 1 over m minus p. So you have to be careful because you can often simplify further than what you get by just combining two like fractions. Let's look at this next one, again a little more difficult. I can see that the denominators are alike, but I also can see that they are going to be able to be factored. So I'm going to go ahead and combine my numerators into 4 plus x over my common denominator of x squared plus 2x minus 8. But before I can be sure that I'm finished, I need to factor that denominator to see if it will have a piece that will cross cancel with my numerator. So this is a trinomial short process. So I'm looking for factors of negative 8 that combine to make positive 2. I believe that is positive 4 and negative 2. So I'm going to say that my numerator is still 4 plus x. My denominator is x plus 4 times x minus 2. We know from a prior video that 4 plus x is the same as x plus 4. They're just in different order addition. So they do cross cancel that unit, and we're left with 1 over x minus 2. So there's still a little bit more work with these than there is with just regular fractions. Let's take a look at how we add regular fractions with unlike denominators. So here I have 7/15 plus 5/12. You may or may not know what the LCD of 15 and 12 is. It happens to be 60. I'm going to go ahead and tell you that. It happens to be 60. So what we have to do is we have to say, what do we do to 15 to get 60? You multiply it by 4, so I have to multiply my numerator by 4 also. What do I do to 12 to get 60? I multiply by 5, so I have to multiply my numerator by 5 also. And I end up with 53 over the common denominator of 60. But we had to first find that common denominator. And then we had to multiply numerator and denominator by whatever it took to get the denominator to be in as the LCD. So we're going to do the same thing with rational expressions, but it is a little more involved, and you're going to have to be very careful how you write these. So let's take a look. I'm adding 5 over 2p plus 3 over 8p. Obviously, they're not like, but the LCD here is going to be 8p. It's what they both go into. So I'm going to write this as 8p, 8p. So notice what I'm doing. I'm writing my new fractions showing the common denominator. And now, just like I did with regular fractions, I'm going to say, what do you do to 2p to get 8p? You multiply by 4. So we're going to do that in the numerator also. That gives us 20. What do you do to 8p to get 8p? Nothing. So don't do anything to the numerator either, and we end up with just 3. Now I have a common denominator, so I can combine those as 20 plus 3 is 23 over 8p. All right, let's try one that's a little bit harder. Here I have an r, here I have an r minus 3. What you want to remember is that an LCD has to represent each piece of every denominator being added or subtracted. So in that LCD, I have to have an r and an r minus 3. Remember, this is its own unit, so having this r doesn't take care of this other one. I have to have both. Now, watch how I'm going to write it. I know that this is my LCD, so I'm going to write r times r minus 3. That's what I'm trying to get to. And then for the second fraction, I'm going to write r times r minus 3, just like I wrote the 8p's on the last one. Now, I'm going to go up to 6 over r, and I'm going to say, what do you do to r to get r times r minus 3? Well, you have to multiply by r minus 3. So we have to multiply the numerator by r minus 3 also. So that gives us 6 times r minus 3. Now, before we go any further, I want to show you something. At this point, if you quit and you cross-canceled the r minus 3's, which you could do, you would end up with 6 over r, which is what you started with. So I know that it's right. All right, now let's go to the 5 over the r minus 3. I'm going to say, what do I do to r minus 3 to get r times r minus 3? Well, for this one, I have to multiply by r. So I'm going to do that in the numerator also, and that's going to give me a 5r. And again, if I cross-canceled the r's, I would be back to where I started. Let's go ahead and distribute this 6. That's going to be 6r minus 18, and then minus 5r all over. Notice I put them together. Once I distribute it, I can put them all together. All over the common denominator of r times r minus 3. Now I can clean this up a little bit by combining like terms. 6r minus 5r is r minus 18 over r times r minus 3. Don't distribute that denominator. You want to leave everything as factored as possible in factored form to make sure that nothing cross cancels. These r's will not cross cancel, remember, because that's a unit. So that is what you get as your final answer, simplified. All right, let's try another one. You may wonder why this one is in this section, because the denominators are already alike, but I have my reasons, and my reason is right here. We learned when you are adding and subtracting polynomials, specifically when you are subtracting, the safest thing to do is change to addition and change the signs on what comes after. That is your safest thing to do in this instance also, because this subtraction sign really belongs to the x and that -2. So that's going to give me my common denominator of 3x plus 1. I didn't need to do anything. It was already matching. Now I have 7x minus x plus 2. 7x minus x is 6x plus 2 over 3x plus 1. You may think you're finished, but you're not, because I can see that I can factor something out of my numerator. So I factor out a 2, and I end up with 3x plus 1 over 3x plus 1, and look there. We can cross cancel that, and my final answer is nothing but just a 2. So you always want to factor if you can to see if anything else will cancel out. Looking at the last one, I'm going to change to addition and change again just to be safe. I don't have an LCD, so for my LCD I need a Q minus 1 and a Q plus 1. So I'm going to go underneath. I'm going to write the new fraction showing the LCD. I'm going to write my 1 up here. Now, how did I get from Q minus 1 to the new LCD? I multiplied by Q plus 1. So I have to do that in the numerator also. I've got a negative 1 up here. Write the new LCD. How do I go from Q plus 1 to the new LCD? I had to multiply by Q minus 1, so I do that in the numerator also. So now when I distribute that 1 in my numerator, I'm going to get a Q plus 1. Here I'm going to distribute, I'm going to get minus Q distribute plus 1 over Q minus 1, Q plus 1. My Q's go away, and I have a 2 over Q minus 1, Q plus 1. That is my simplified answer.